Dear students, let us now look at another interesting question from this topic on alternating currents. The RMS value of the alternating EMF E is equal to 8 sin omega t plus 6 sin 2 omega t volts is. Now usually you are very clear with how to find the RMS value, dear students. If I have an equation E is equal to E naught sin omega t, you know that E naught is the peak value and RMS value of which would be E naught by root 2. Here we have a combination of or a sum of two sinusoidal functions. E is equal to E1 sin omega t plus E2 sin omega t. Is it not? So now when we observe this, we need to apply some simple trigonometry and find out what is going to be the peak value. By the end of it, I am also going to tell you a shortcut for solving this. So let's observe this, dear students. One of the ways is going to be, so we are given the voltage which is E is equal to 8 sin omega t plus 6 sin 2 omega t. One of the ways is using trigonometry, another way is using calculus. Let me tell you both the ideas and then we are going to solve using a simple shortcut. See here, when you use calculus method, the idea is very simple, dear students. When you are using calculus method, peak value, that refers to the maximum value of a function. You know that a function f of x reaches maximum when the first derivative becomes 0 and the second derivative is going to be less than 0. So here we are going to find out dE by dt and equate it to 0 and then find d square E by dt square, and that value should be less than 0 for E to be maximum at that value of t. This is one way of doing it, that is using calculus method. Another method is using trigonometry, where suppose if I have an equation V is equal to V1 sin omega t plus V2 sin omega t, I can divide and multiply by root of E1 square plus E2 square. Then E1 by root of E2 square plus E1 square can become a sine of some alpha. E2 by root of E1 square plus E2 square can become cos alpha. Then you may use cos A cos B plus sin A sin B form or sin A cos B plus cos A sin B form and accordingly get an expression for the peak value of the EMF. Anyways, we are going to skip both the methods and we are just going to use a shortcut. So let me tell you, if you are going to have sum of two functions to be the instantaneous value of an EMF or a current, then the peak value is given by the square root of the amplitudes of the individual sinusoidal voltages. So the shortcut is E naught is going to be equal to square root of this E1 square plus E2 square, which is nothing but 8 square plus 6 square, which is 64 plus 36, which is 100. Root of 100 is going to be 10 volts. Therefore, E naught, the peak value of the alternating EMF is going to be 10 volt. But dear students, what we are asked is, we are asked not to find the peak value, but rather the RMS value. So ERMS, we know that ERMS is equal to E naught by root 2, which is nothing but 10 divided by root 2, which is nothing but 10 divided by 1.414. So the value is going to be less than 10. The only value which is less than 10 is 7.05 volts. So 7.05 volts is going to be the right answer, which is going to be the RMS value of the alternating current. So the right answer for this question is the very first option. I hope, dear students, you have been able to clearly understand how to solve this sum. If you are given V is equal to V1 sin omega 1t plus V2 sin omega 2t, then the peak value of the voltage is going to be root of V1 square plus V2 square. Once you find that, you can go ahead and find the RMS value by using the formula VRMS is equal to V naught by root 2. I hope it is very clear to you, students, how to solve this particular question. you.